back. Today we're going to look at some algebra, specifically long division. The expectation with this video is that it won't be too long, hopefully around the 10 or 12 minute mark. We'll go through a number of examples. We'll look at basic long division, and then we'll look at some algebraic long division answers, and we'll see what their implications are for all of algebra. So the first few things that we should discuss or remind ourselves of before we jump into this is what a numerator is. So a numerator, sometimes it's called a dividend, and what that basically is it's a number that is going to be divided. So typically in a fraction, it's the number that's on top. The denominator, that is also known as the divisor, and that is typically the number on the bottom, and that's the number that we are dividing into the numerator or the dividend. Okay, and a factor. So if we think about factors, maybe we've talked about them in algebra up to this point, and if we haven't, let's just think of what a factor is in terms of everyday life. If somebody said that something is a factor in an event, that means that it's really played a role in that event's creation, or it's been a very important part in this event coming to be. And that's the same for algebra. If we have something, an expression, and it's a factor of another expression, well, what that means is it's a building block in the creation of the other. And we'll see specifically what that means as we go on. I know that these explanations might seem quite general at the moment, but as we move on through these questions, hopefully we'll see what the specific implications are of these. So this is typically how our algebraic long division is presented to us. It can seem very overwhelming just to look at like that, but what we will find is that the manner in which we solve these is very repetitive, and if we can get the hang of it over a number of examples, then it's very applicable to all other examples we will come across. But first, let's just run through some basic long division, just to remind ourselves of things that we would have seen in primary school. Okay, so say we had the number 1023. Okay, and I want to see if 3 is a factor of that, or 3 divides evenly into 1023. Well, of course, I have my calculator. I could just punch it in there and get an answer. But what if I didn't have my calculator? So let's do some manual division here. Okay, so we set up our long division, 3 into 1, 0, 2, 3. Okay, and now we move typically from left to right to try and solve this. So how many times does 3 go into 1? Well, 3 doesn't go into 1, so it goes in 0 times, remainder 1, and we bring our 1 up here, and that now becomes a 10. So how many times does 3 go into 10? Well, it goes in 3 times, remainder 1. So we've dealt with our 1 and our 0 now. Now we have 12. 3 goes into 12. Hopefully we all know that that is 4 times. No remainder. And then finally we have 3 goes into 3 once. Okay, and what that has told us is that 3 is a factor of 1023 because it has divided in evenly with absolutely no remainder. And conversely, if we thought about it, 3 times 341 gives me 1023, right? So that means that 341 is also a factor because it goes in 3 times to 1023. So essentially what a factor is, in very basic terms, is it is an element that will divide evenly into whatever our numerator or dividend is. Okay, so that is just a basic example of what it looks like with just a pure numeric example. Alright, so here we refer now back to our algebraic division example, and on top we can see its structure is very similar to that of just our numeric long division. We have our numerator or dividend on top in green, and then we have our divisor or denominator on the bottom in orange, and I've set those up in the exact same way. Numerator goes inside our division and denominator is on the outside. Some similarities and differences between these guys in terms of our numeric long division and now our algebraic long division. Its structure is similar. We move from left to right just as we did in the last example we will carry things forward from step to step. And then our differences are obviously the fact that in this example we have variables. We also have powers with some of the variables, like so it's 6x cubed plus 5x squared minus 10x to the power of 1 and so on. So that is a distinct difference. Another difference that we'll see is instead of carrying things from left to right, we're actually just going to carry them down the page to make our lives a little bit easier, and to just sort of close off a step. Once we've completed it, we can park it and move forward. Essentially what we're considering here is how many times will 2x minus 1 divide into this, and we're also interested to see if it divides in evenly. And if it does divide in evenly, meaning that there's no remainder, what we can then say is that 2x minus 1 is a factor. One thing we should also consider as we engage in this is another way to think of our division is, you know, if I were to ask you how many times does 2 go into 10, another way to ask that would be, well, what do you need to multiply 2 by in order to have your answer as being 10? And we know that 2 goes into 10 5 times, and likewise 2 times 5 would result in 10. So that's another way to consider it, and I'll probably refer to that method throughout this example. Both ways of considering it are just as valid as the other. It's just some people find certain ways easier. So let's jump into this. Obviously on the left hand side now we have 2 elements, and we'll just take note of how we deal with those as we go. So first things first, 2x. How many times will that go into 6x cubed? Or in other words, what should I multiply 2x by so that my answer would be 6x cubed? Well, 2 times 3 would give me the 6, and x times something would give me x cubed. Well, x times x squared would give me the x cubed. Okay, and now because there's a second element, we can't you know, forget about that or just leave it be. We also need to deal with that now. So let's start to move things around a little bit. So 2x times 3x squared, well, we said that that would give us our 6x cubed here. And now our second element needs to perform a multiplication against what we've just found. So minus 1 times 3x squared, that would give me minus 3x squared. Okay, and the goal here is to hopefully start to cancel things out. So I'm going to draw a line under that, and in order for things to cancel, what we should see is that they should be equal, and then we could hopefully change their sign. So I know that plus 5 and minus 5 cancel, or in other words, they give me a result of 0. But right now, both of these guys are positive. The 6x cubed and 6x cubed are positive. So in order to kind of work around that, I'm just going to change the signs of everything in this new line. So our 6x cubed became a minus, and our minus 3x squared became a positive. And now 6x cubed take 6x cubed, well, they cancel or they result in 0. I'm just going to put that there for our sake. It's not necessary to show it. And now I have 5x squared plus 3x squared. Well, that would give me plus 8x squared. And I'm going to bring down my minus 10x. So essentially that is line number 1 complete. So now with line number 1 complete, what we're doing is pretty much repeating this step, and it's the same. Obviously our numbers are different, our variables have different powers, but the way that we've done it, the method, is what we're going to continue with. So now we consider 2x. How many times will that divide into 8x squared? Or in other words, what should I multiply 2x by to give me 8x squared? Well, I know that 2 times 4 would give me the 8. Alright, and then x times what would give me x squared? Well, x times x, so that would be 4x there. And if I now perform that multiplication, well, 2x times 4x gives me my 8x squared. Okay, and now I have minus 1 times 4x, that would give me minus 4x. We're doing the exact same thing again, so we're looking to hopefully cancel out our 8x squared values. I know that in order to do that, I should change their sign. So 8x squared becomes negative and minus 4x becomes positive. these two guys will cancel, leaving a remainder of 0 as such. Again, don't need to have that there, but it's helpful to have it. And then minus 10x plus 4x, well, that would give me minus 6x. Okay, and now I bring down my final value, which is that plus 3. And now I have one final line to go, and I start the process once more. 2x times what would give me minus 6x? Well, 2 times minus 3 would give me minus 6x. And now I perform that multiplication. 2x times minus 3 would give me minus 6x. And minus 1 times minus 3 would give me plus 3. So, pretty interesting here. Both lines are now identical. Both values in each line. Again, we would like for them to cancel, so we change the signs. The plus 6x, or sorry, the minus 6x rather, becomes a plus, and the plus 3 becomes a minus. Alright, minus 6x and plus 6x cancel to give me 0. And also, plus 3 and minus 3 cancel to give me 0. So what that means is we've completed this question. There is no remainder. We're not left with anything at the end. Everything cancelled out perfectly for us. So what that tells us is that 2x minus 1 divides into 6x cubed plus 5x squared minus 10x plus 3. It divides in evenly with no remainder. And what it also means is that 2x minus 1 is a factor of 6x cubed plus 5x squared minus 10x plus 3. Okay, it's part of the building blocks that make up this expression. Okay, so our algebraic long division here is completed. There's nothing further we can do with this, but I want to show you now sort of what it implies to be a factor. And I've established that 2x minus 1 is a factor, and as a result of my calculations here, I can also say that 3x squared plus 4x minus 3 is a factor of this expression. So what I'm now interested to do, and this is totally separate to our long division, what we're about to see isn't part of the solution to the long division as such, but I would like to multiply 2x minus 1 by my solution of 3x squared plus 4x minus 3. Okay, and I have that prepared here, and I'm going to go through this relatively quickly. So 2x times 3x squared, well, that would give me 6x cubed. 2x times 4x would give me 8x squared. 2x times minus 3 would give me minus 6x. Minus 1 times 3x squared would give me minus 3x squared. Minus 1 times 4x would give me minus 4x, and minus 1 times minus 3 would give me plus 3. I'm now going to tidy up this expression. So 6x cubed remains as is. I have 8x squared, take 3x squared. Well, that would give me just 5x squared. I'm going to cancel these guys out once I've dealt with them, so I know I don't have to consider them again. I've minus 6x squared minus 4x. Well, that would give me minus 10x. And then finally, I just have a plus 3. So if I multiply out 2x minus 1, or my divisor, and 3x squared plus 4x minus 3, my solution to the last question, it leaves me with this, and hopefully this looks familiar because it's what we started out with. Okay, it was our numerator. So what that tells us is that both of these two guys here are factors, and if I were to multiply the two factors, it brings me right back around full circle to the numerator or the expression that I was really beginning with on top of our division or on top of our fraction. Okay, so that's kind of the full loop there of our long division, and seeing that we are left with two factors and then what exactly those two factors mean. Okay, so here we have another algebraic long division question. Hopefully this one we'll be able to solve a lot quicker. We could see how the question was presented to us here in a fraction. I put the denominator on the outside, and obviously our numerator or our dividend was on the inside of the division. So now we start again, obviously working from left to right. we're considering x goes into x cubed how many times, or what should I multiply x by to give me x cubed? Well, that would be x squared. So x times x squared, that would give me my x cubed, minus 1 times x squared would give me minus x squared. Alright, and now I think about how I might be able to cancel these. Well, I change the signs of this line here. If it was a positive, it's now a negative, and vice versa. So x cubed minus x cubed cancels, gives me a remainder of 0 as such. And then I have minus 4x squared plus 1x squared. Well, that gives me minus 3x squared. I bring down my plus 3 and I start the process once more. X goes into minus 3x squared how many times? Well, it goes in minus 3x times. Okay. Alright, so x times 3x, that gives me minus 3x squared, and then minus 1 times minus 3x gives me a plus 3x. Alright, and maybe we've spotted something here, but let's continue on and we'll see how it works out for us. So this one here becomes positive, this becomes a negative. These two guys will cancel, and now we bring it down to another line. So what we've encountered here is a problem, because one of these values is obviously a constant, our plus 3, and the other one is a variable. But that's okay. This is something that we are still able to solve. It should have been easily spotted from the first line. Hopefully when we become more familiar with these, it is something that we'll spot easily in the first line, is that we had x cubed, we had a minus 4x squared, and then it just went to a constant. We should have ideally had an x value there, a variable, and the coefficient of it should have been 0x. And we could have inserted it at the time, we could have popped a 0x in there, but it's fine that we didn't. We're just going to bring these two values down to the next line now. So what we have then is minus 3x and plus 3, and we just go at the process again, just like we did last time. So x times what gives me minus 3x? Well, x times minus 3 gives me minus 3x. Now x times minus 3 would give me my minus 3x, and minus 1 times minus 3 would give me my plus 3. Alright, and finally we're trying to cancel these once more, so our minus 3x becomes a plus, and our plus 3 becomes a minus. These two will cancel, plus 3 and minus 3 also cancel. We have no remainder in this question. So what we've said here basically is that x minus 1 is a factor of x cubed minus 4x squared plus 0x plus 3. Hopefully we'll become more familiar with spotting little things like this as we move on, but it wasn't a big deal that we didn't spot it straight away. It was something that we could have and we did rectify later on in the question. So this is just a second example of our algebraic long division. And likewise with x minus 1 being a factor, x squared minus 3x minus 3 is also a factor of this expression here in green. Okay, so the things we're hopefully taking away from this video is that our algebraic long division isn't all that different from our numeric long division that we saw in primary school in 5th class, in 6th class. The foundations of it are very much the same. It's just slightly more complex because we're now dealing with variables and powers and different elements like that. But again, foundations are very similar. Hopefully we're now very familiar with the concept of a numerator or a dividend, and it being the value on top of the fraction, so the value here in green. Hopefully we're familiar with the denominator or the divisor, it being the one in red on the bottom of the fraction, or the number being divided in. And then finally factor, that if it divides in evenly, it is a factor. A factor is just another way of saying that it is an element that helps create the expression that we have here in green. So if x minus 1 is a factor of this numerator or this expression, well, that means that it can be used to build this expression. And that's it kind of in very basic terms. Obviously it does get a little bit more complex and a little bit more challenging, but if that's what we've taken away from this video, we're very much on the right track.